To demonstrate how beamforming works on the 1250, let's take a look at two element transmitters. In this demonstration, we're using the combined energy from both element transmitters to focus on a specific location. When the laptop moves, we can use beamforming to recalculate the energy so it moves along with the laptop. Now let's take a look at a skyward view of the radiating patterns from each element transmitter. As you can see, the pulses are identical from each transmitter. As the rings radiate out, you will see points in which they cross and in points which they don't cross. The points in which they cross create a phase amplitude, effectively higher signal at that location. The normal gray rings indicate standard transmission power from any one element. In this example, we will place a laptop in the non-beamforming pattern at a coverage hole location. Minus 80 dBm is normally the signal strength where connectivity is compromised. Now that we know the location of a coverage hole on a non-beamforming pattern, let's take a look at what happens when you use beamforming. As you can see, both transmitters again are transmitting, but the top transmitter is 10% out of phase with the bottom transmitter. This moves the crossover points, and as you can see, the crossover points are now directly at the laptop location. This virtually changed the signal strength at that location to move the laptop out of a coverage hole. Now let's take a look at how beamforming performs in an actual facility. Here we are zooming into a building in which a site survey was performed. Let's take a close look at the 4th floor where this was done. If you notice, on the far left-hand side, in the middle of the building, we will place an access point, the AP 1250. The animated character moving throughout the building indicates the physical survey that was actually performed. Each red square indicates a sample point. The colors indicate the signal strength. As the person moves closer to the AP, the signal gets stronger. And as the person moves further away, the signal strength gets weaker, indicated by the color chart on the right-hand side. Now let's take a look at the real site survey data performed on the floor. First, we'll view the non-beamforming survey. You can see the path that was taken and all the red squares indicating the sample spots. Moving our arrow to the furthest sample spot, we'll view the signal strength at that location. It's indicating minus 84 dBm. Moving that data down, let's load the beamforming survey. Again, moving our arrow to that same location, let's view side by side the two signal strengths. An increase of 10 dBm just by enabling beamforming.